Welcome to the NVIDIA DGX-1 webinar hosted by GPL Technologies. GPL Technologies is a company that is an elite partner with NVIDIA. So we integrate NVIDIA into the workstations we create, and they're one of our top partners. And so we wanted to get the messaging out today of their latest and greatest technology, which is the DGX-1. A little bit about GPL Technologies is we do customized IT services for creatives. We design, implement, and support innovative solutions that are tailored to your business goals and needs. We deal heavily in the creative field, and the services that we offer are managed services. We do hardware as a service, which is our rentals division, and we do infrastructure solutions, and we also do technical staffing. And we have lots of fantastic partners, and our absolute top partner is NVIDIA, and we are going to educate you on their great new technology, DGX-1, and I have the wonderful Steve Harpster who will be presenting. So take it away, Steve. Let them know about this great technology.
Great. Okay, thank you, Melissa. And again, my name is Steve Harpster. I'm a solution architect for NVIDIA, and I'm based in actually in Santa Barbara, so a little bit north of where GPL is. And been with NVIDIA for about 14 years now, and have done about every product we've come to market with. So we're going to talk today about our new NVIDIA DGX-1, and I know that there's a chat window, and I know Melissa and some of the other NVIDIA folks that are on the call will be trying to monitor that. I will also try to monitor it, so if you have questions, that's a good way to be able to ask one. So with that, let's get started. So most of you probably know NVIDIA, and you probably know NVIDIA from either gaming or possibly if you're in the M&E market down in the Los Angeles, Southern California area, you may know us for rendering. So this is a little bit different, what we're going to talk about today. So I'm going to give you a little bit of background on the GPU, and when I say GPU, what I'm talking about is a graphics processing unit. It's the actual chip that does the computation or the rendering of the content that you're looking at. So when I say GPU, that's what I mean. The GPU, as you know, it evolved really from a 3D graphics chip that we started early on with in NVIDIA. And it evolved from not only just a 3D graphics pipeline processor, but now it's used for many, many things, including high-performance computing and computational analysis. And so that 3D graphics chip that you know and love probably from your gaming days has now transformed into really a computer brain that allows humans to have the power to simulate virtual worlds and also have computers that have the intelligence to understand the real world. So our whole graphics processing unit now spans from gaming to virtual reality to artificial intelligence and deep learning, as well as self-driving cars. And I'm going to talk a little bit more about that as we get forward. But let me give you an idea of why the GPU is good for not just graphics, but also for computation. So you guys are looking at a screen right now, you know, and it's over probably 1 million pixels based on your resolution that you're looking at, but let's just call it 1 million for time's sake here. And so every pixel that's on there, all of those 1 million pixels have a component to them, typically a red, green, blue component that you're actually able to see and display the screen with, and that's why you get your different colors and things like that. So why is the GPU good at being able to do that? And I'll explain to you that when you're actually looking at a screen and each of those pixels have an RGB or red, green, blue component to them, what happens if I want to go ahead and change the red component of all of those pixels? In many computational cases, and the CPU being one of them, central processing unit, they would work in a serial task, meaning that I would have to change each red value of all of those pixels one at a time, one by one. I'd go to number 1, number 2, number 3, and so on. But what's so great about the graphics processor and what allows us to actually use it for computation is that if I want to change the red value of those pixels that are on your screen right now, I can do it all at the same time in what we call a parallel process. So the GPU by nature, and by nature of graphics that we've done in the past, does things in parallel. There's a lot of cores, there's a lot of things that can be changed, and if I want to change the red value, I can do it all at the same time in a parallel process. So that said, we have now opened up the environment for the GPU not to be just used for graphics, but to be used for GPU computing, for deep learning and artificial intelligence. So let me give you a quick example here. If you look on the screen there, we're going to talk about an example of a deep learning aspect using a data set of images. But the first thing I want to kind of talk about is, so 10 years ago, we really opened up these GPUs to be massively parallel processors. And to that end, we saw scientists and researchers jump on the GPUs. And they started out by using the graphics processor, the GPU, for things such as molecular dynamics simulations. They also used it to look at 3D CAT scans, to look at our organs. And they've even done things such as in-body studies in astrophysics, where you're actually seeing how all of the bodies in a galaxy interact with each other. So all of these are simulations and computations that need parallel processing, and that's why the scientists and researchers were able to jump on it and use it so efficiently. So now, fast forward a few years, and because of that parallel nature, artificial intelligence researchers have already also discovered that and are starting to use it for AI and deep learning or deep neural networks out there for computation. So the combination of a deep neural network, big data, and these powerful GPUs have really reignited AI, and we're going to talk a little bit about how that's going to work with this model that you see in front of you. So what I start with is a huge data set, and this may be a collection of images, 50,000 images, let's say. And I can categorize them to some degree based on what I'm actually going to train my deep neural network to look for. So as I feed these huge amounts of images into the GPU, and again, with parallel processing and learning algorithms that are optimized for actually learning from these images, I can actually come up with what we call a trained network in the end, such that if I now input something like the picture you see there of the child with the cake, the deep neural network that's been trained by the GPUs is actually going to be able to say, hey, I recognize this because I've learned from the images you gave me before, and this is actually a child that is eating a piece of cake. So that's kind of the pipeline. You feed the GPUs, they learn from it with algorithms that have been optimized, and then you can input other sources so that that trained network can actually take a look at what you're trying to learn about. Let me back up. Another example, just so this kind of comes together, I talked about self-driving cars. Same kind of deal. We've actually been able to team up with some of the driving manufacturers or the automobile manufacturers out there such that they can train their computers that actually go into your system on a chip in a car. They'll be trained to know what a pedestrian is, what a crosswalk is, what a speed limit sign is, and what that speed limit actually is. So by training all of these models, you can actually roll it out in practical instances today with the self-driving and autonomous cars that are out there. So those are two examples of how we're using deep learning today. So the GPUs have been great for this, but typically they've been servers or single GPUs that people are using. And what we've done today is we've actually combined our GPUs and some other technology into a box called DGX-1. And it's simply an artificial intelligence supercomputer in a box. So we know that deep learning holds enormous promise, but it requires huge amounts of computing power. And so those are typically HPC-like clusters which are hard to build and maintain. And so what we've done is we've actually been able to come up with this DGX-1, and it's a plug-and-play appliance that has the computing power of what would be equivalent to a 250-node Intel CPU HPC cluster. So included inside this box that can be comparable to 250 CPU nodes are 8 of our Tesla P100 Pascal chips with 16 gigabytes of memory per GPU that's in the box. In addition, we've come up with some technology called NVLink, which allows us to be able to talk very efficiently and very quickly among the GPUs that are in the system and actually aggregate the entire amount of memory so that it appears to the system as one big GPU and with, in this case, 128 gigabytes of memory by using NVLink to be able to aggregate that. Included also are 2 of the high-end Xeon processors, some 8 terabytes of storage in a RAID configuration, and it also has the ability to be node and networked together through either InfiniBand or with dual 10 gigabit E interfaces that are on there. This is all in a 3U unit. It does require 3,200 watts of power, and we'll dive a little bit deeper into that here as we move forward. Okay, so let's talk about what had to happen for us to be able to combine this 170 teraflop machine equivalent to 250 CPU nodes into one box. And so it took 5 things that had to come together. The first one, of course, is our newest architecture on Pascal called the Tesla P100. And they're really the brains of this entire operation, if you will. Additionally, with that same chip, the new Pascal chip, we were able to include a new manufacturing process called 16 nanometer FinFET processing. And basically what that allows, and you can kind of see in the picture there, the GPU actually has a thin type of affinity to it that allows us to use that extra real estate to be able to apply more transistors onto the chip itself. So the FinFET manufacturing process helped us with more transistors in the real estate that we had to work with. Third, we came up with something called HBM2, or high bandwidth memory, that actually allows us to stack the memory together in like a tower in a sense, so that we can now get more memory on the chip set as well as using it in a smaller form factor by just stacking it on top of each other. The fourth thing was that NVLink that I mentioned briefly. NVLink is what is our own proprietary interface to our GPUs that allow us to be able to communicate quickly and efficiently amongst all the GPUs that are in the system, as well as aggregate all of the memory together so it looks like one big GPU and one big set of GPU memory. And then finally, we've had some new artificial intelligence algorithms that I'll go into in a little bit more detail here in a minute, but that has allowed us to optimize and get the highest performance out of this box. So the DGX stack, let's take a look at that. It looks something like this diagram here. Basically, we start with a Linux server OS, and in this case, we're using Ubuntu on the bottom floor there. Secondly, with our optimized GPU driver that allows for CUDA support, we put that on. But we've added 3 new components on this DGX stack itself. One of them is called NV Docker, and this basically allows you to run containers. And if a container is basically a self-contained application that can be run on the box itself. So it can be mixed framework environments because everything is contained within that particular container and pushed out through NV Docker. Additionally, we've added some optimized libraries for cuDNN, which is deep neural networks, so CUDA deep neural networks, and also NCCL, and that's basically the software that allows us to communicate efficiently and quickly with the GPUs that are in the box. And then on the top, we've got the digits software, which is basically your interface and a GUI that allows you to use very quickly and easily some of the frameworks that are set up today for deep learning, like Caffe, Torch, and Theano, for just a few examples. So out of the box, you get instant productivity. Basically, it's plug and play. You assign a few things like IP addresses and plug it in, and you're ready to go with the AI frameworks that are there. It's optimized by our developers in-house, and we can update it remotely via the cloud with push-like environments to have it on the latest and greatest code that's out there for the deep learning software stack. And you also, with this, are going to get access to some of the solution architects that are deep learning architects and experts to be able to help you move forward there. So the DGX itself is an essential tool that is that we feel like deep learning scientists need. So deep learning, of course, as you know, it has enormous promise for every company, but it needs the computing horsepower of a supercomputer really to take advantage of it. So it takes a ton of compute to be able to train and implement a network. So a lot of the IT departments that are out there today don't want to really deal with supporting and building a 250 cluster server environment in a data center. So again, we've taken kind of the pain out of the building and maintaining a supercomputer, and we've shrunk it into the DGX-1. With that, once it's up and running, the DGX-1 can reduce your training time from seriously weeks to days in many cases. And I've got some examples here coming up. But that allows all of your researchers and your deep learning scientists to actually iterate more so that they get more runs, and they can tweak and tune and get better and more accurate results out of your trained network. Additionally, it also allows more people access to it so that you can have more deep data scientists using it because the jobs are taking quicker to get through. And we're also finding that many of the artificial intelligence pioneers, and you'll see folks like the folks at Berkeley, Stanford, Carnegie Mellon, for instance, that are actually taking advantage and have gotten on board with us. So many of our first units that we've shipped are going to these AI pioneers that are out there today for DGX-1, and they're actually in the field and working with them today. One of the most interesting people that we've worked with in the past is a guy named Andrew Ng from, he's at Baidu now, and he's one of the central figures for deep learning and the resurgence of AI. And just a little backstory on him, he used to be, back in 2011, part of the Google Brain project that had done some really amazing things. They had deep learning set up in their cluster environment, which was 2,000 CPUs in their HPC environment. And they actually used that to be able to have these deep learning nodes take a look and look at YouTube videos that were out there today. And so they were able to achieve results where it was learned to recognize cats. And you're going to ask, why cats? Well, cats are actually probably the most common YouTube video that's out there today. So they were able to get it to learn and recognize what cats were, and also specific people, by just watching and learning from the YouTube videos that are out there today. But when they did that back in 2011, it required about 2,000 CPUs in the servers they had at one of Google's giant data centers. So really, not many people have the ability to have a 2,000 CPU setup that needs to be powered and cooled within their reach. So NVIDIA went and spoke with Andrew and his team at Stanford and asked them to consider using a GPU for the same type of thing that they were doing with their 2,000 CPU node HPC setup. And as it turned out, they were able to get the same results with 12, and that's the number 12 NVIDIA GPUs as they could with the same performance of 2,000 CPUs that they had out there working on it. So we had great success out there going from 2,000 CPU core, or CPUs, not just cores, but CPUs themselves, down to 12 NVIDIA GPUs. And Andrew went on to head up at Baidu, and he is an AI chief scientist over there and is actually interested in working with DGX-1 as well. Okay, so let's take a look at some of the performance numbers that we've been talking about here. This is a kind of an eye chart. I apologize, but you can see there that on the far left is a Titan X board, a single Titan X board that's out there today. And we're calling that the baseline, or 1x relative training performance, using some of the standard training data sets that are out there for deep learning, such as AlexNet, ResNet, and Microsoft Research Group Net as well, just to name a few. And as you see as we go over to the right, that in some cases we're up to 16x faster on the training of these data sets than just a single GPU. Now, this is the money slide, literally. So how much is it going to cost for me? So a single DGX-1 today, manufacturer suggested retail is $20,000. And I want to be able to put that into a little bit of perspective here on what you get for that. So remember that we compared one DGX-1 to about 250 Intel servers. Let's dig a little bit deeper down into that Intel configuration so that you kind of can get an idea of what that would cost versus a single DGX-1. So just to have the infrastructure itself with an Intel configuration, that means, and infrastructure I mean switches and cables and racks, you're going to have that in order to get started. And we estimate that's going to be about $435,000 of just infrastructure. And that alone, which contributes really to zero work in your deep learning job because you need it just as infrastructure, is really the cost that you could get 3 DGX-1s for that, just that infrastructure cost. So now let's take a total look at the cost of the system. And so we'll take those 250 servers, which are about $2.5 million combined with the $435K for just infrastructure. You're at $2.8 million for a system, and for that same price, with 250 nodes of Intel-based CPUs, you could buy 22 of these DGXs, and you'd have a system that would be on the top 500 list for the supercomputer list. So my point is, performance is one thing, but as data centers are limited on space and power, it actually is a very good value for the price compared to if you did just the base. So with it, as I said, NVIDIA expertise comes with it. So with a DGX purchase, you not only get NVIDIA, but you'd get GPL assistance to be able to set it up, support it, and optimize it. You also would get access to deep learning, our Deep Learning Institute, which is a certified expert instruction. And that allows you to go to Deep Learning Institute sessions online or even in specific geographies of the world that we run them. We also have GTC conferences set up worldwide that can be attended. And finally, because of partners like GPL, you have access to our global network of partners to allow you to be able to do setup and help in the field as well. Some of the partners that we're working with right now to make DGX a reality, you have massive amounts of data that you have, and how do I analyze that? Well, we've partnered with some of the people on the far left there that are graph analytics providers that allow you to take that data, analyze it, and graph it out into a visual environment to help you understand what the data is you're looking at. We also have worked for GPU Accelerator DL frameworks that we talked about, Caffe, Theano, Torch, just 3 of them that I can rattle off the top of my head. But we've also got enterprise-level deep learning partners as well, such as Cinescope, and then, of course, services and data as well. So we can talk about the GPU. You could get started as really you can kind of walk before you run if you want to. Any of our GPUs that are out there today and I should say within 3 or 4 years of being released, will support CUDA and deep learning to a degree, meaning that if you have a single Titan X in a system, you can get started with this today. Once you have things worked out, you can move up in a number of ways. One is the DGX-1, of course. We've also got GPUs that can be used and provided by many of the OEM partners that are out there today. But we've also got partnerships with hub providers that you see listed. Just kind of to summarize here, DGX-1 again is an appliance that is fast and instantly productive with very minimal configuration to get it on your network. Additionally, I want to give you a sneak peek of something that's coming down the pike. We've talked a lot about deep learning, but I want you guys to know, I'm going to give you a sneak peek that deep learning is one aspect of this box. The other one is that we are actually going to be putting on rendering software so that folks that are in the media and entertainment space can actually use these boxes as a rendering box as well. GPL in the past has sold a product called the VCA, the Quadro VCA, and so we're planning on using this same type of DGX-1 box, but we're going to add some different softwares on it such that it can be used as an interactive rendering box as well. So if you're familiar with the VCA in the past, we've had something called an iRay server that's been on the VCA that allows folks to actually interact in a very, very good, almost real time, their large scenes in 3ds Max, in Maya, in Rhino, and also in Cinema 4D that allows them to render and get a preview very quickly and move it around in the scene to look at what the lighting looks like, look what the materials look like that are applied onto it. And we're planning on taking this to the next level with the DGX-1 software as well. So VCA, what used to be VCA, will become VCA Next on the DGX-1. Additionally, we've also announced, and this is some of the announcements from SIGGRAPH, that was a show that went on about 2 weeks ago down in Anaheim. We actually announced a product that we're also going to be coming out with that GPL is very involved with some of their clients, called MentalRay 3.14. We like to call it PyRay for 3.14, but it's basically MentalRay being GPU enabled and able to take advantage, since MentalRay is a very, very common renderer out there today that traditionally has been CPU based, is now going to be GPU based, so that many of the benefits that you got with rendering a MentalRay can now be offloaded and used with the GPUs themselves. So really, that's about what I wanted to cover with you guys today. And so, Melissa, I'm going to have to rely on you to see if there's any questions at all that I can answer in the chat.
It looks like we do have one question. Is there any info you can divulge in regards to the iRay VR?
Good question. So yes, that's another thing that we actually released at SIGGRAPH, and the iRay VR is something that we've actually implemented into iRay with 3ds Max and Maya today, such that what you're able to do is able to apply materials and lighting using iRay, the photorealistic based renderer that we make. And now you can actually cut them out, or actually export them out in what we call a new command in iRay called spherical camera. And what that allows you to do is actually be able to get a 3D volume of your scene that you've worked on in Max or Maya, and be able to then put that into a VR viewer. And this VR viewer today is not a product that's available, but we're working on productizing that as well, such that now users can stand within a volume and be able to actually see it in real, with real shading, real physically based materials, and in VR, such as you're getting the stereoscopic effect, and be able. So let me give you an example. We're thinking about people that are architectural firms or real estate guys, for an example, where now users can actually do a critical design review in VR with the client using their own scenes and their own materials, such that that new spherical camera that will come out for iRay VR will allow you to actually look and be as if you're in that volume in a virtual environment, either on HTC Vive or on the Oculus Rift as well.
That was Park Sanjit who asked that question. I have another question, which is why would I want to pay twice as much for the DGX-1 compared to the Quadro VCA?
The Quadro VCA is a discontinued product very soon, and we feel like we need to refresh that product, and so the follow-on is going to be the DGX-1. But there are going to be companies, and GPL may be part of this, I won't speak for them, but that can actually create smaller versions of the DGX-1 with the Pascal add-in cards that are going to be coming out, the P5000 and the P6000. So if the DGX-1 is a little bit too much for you to take on at this time, there will be other partners that are going to be coming out with solutions that take advantage of the Pascal architecture for things such as the VCA did with rendering.
Then I've also been asked, there's someone that's interested in TCO of the DGX versus custom built.
Well, right now, that's not possible for a custom built because these, the only people that are making the DGX-1 today, and we hope this changes in the future, is NVIDIA. So the P100 that are actually in the DGX-1 are actually not like your traditional add-in graphics cards that would go across, say, a PCIe slot or something like that in a workstation or a server. These P100s that are in the DGX-1 are actually pinned and soldered down on the main board of the actual DGX-1 unit itself. So right now, there's not others that can make this. We're the only ones, but we're hoping to work with some of the the OEM vendors to allow them to do something similar to what we've done with the P100 that's on the main board in the server.
I have a follow-up question actually to the iRay VR. Wanting to know information in relation to creating a volumetric format. Will this be possible through a service or a standalone program?
So again, yes, we're working with others that can take advantage of making software for the viewing of this volumetric or spherical camera view that we've got implemented with iRay and 3ds Max and Maya. However, today NVIDIA is the only one that has a viewer, but we are working with partners to be able to hopefully have that a little bit picked up more in the ecosystem. But it is not a product yet, but we hope to not only offer it ourselves, but hopefully for others that may be able to offer it in a viewer.
Will Max users be able to render out of their machine a volumetric format for iRay VR viewer?
Yes, it's a camera, a spherical camera view that comes with the iRay plugin, so that you get the volume at this point is not something that is interactive, meaning that you're standing in a single position from the spherical camera view, but you're able to view it in VR. Now, creating the volume is probably a logical step, but that is not something we're doing at this point.
Is the DGX-1 and the spherical viewer compatible with a cloud-based service?
So the DGX-1 does not support this yet. That was the sneak peek that I gave you, that we're going to eventually get there. So the answer is when we get there, the DGX-1 will certainly support any of the functions that come with our iRay software that we create, and that includes the spherical camera view for VR. If the cloud providers that are hosting the DGX Next, or the VCA Next we'll call it, and they offer that as a cloud service application, then the answer should be yes, it will support that kind of setup. But we're a ways out from that, guys. I mean, because we don't even have the iRay working. I just gave you a sneak peek there of what's coming down the road.
You've answered a lot of really good questions, and so I think there's been a lot of good information coming out there. And like I said, GPL Technologies is absolutely a huge supporter of NVIDIA. We are an elite partner of NVIDIA, and we are always doing events and educations on their latest and greatest technology, which we use to integrate in creating workstations for media and entertainment primarily, and other areas too. That NVIDIA is absolutely very integral part in the design and implementation of the infrastructure that we use. So thank you so much, Steve, for your great presentation.
You're welcome.